All right, so moving right along, our next speaker is Todd Jabobs from NOAA. Todd is the Deputy Superintendent of the NOAA Channel Islands National Marine Sanctuary. He also serves as a Chief Technology Officer for unmanned systems for the NOAA Office of National Marine Sanctuaries. He's been actively involved in the NOAA Unmanned Aircraft Systems program since its inception in 2004. His principal area of interest is marine monitoring with UAS. He has conducted UAS operations in the Arctic, Antarctic, Atlantic, and remote Pacific Oceans. Todd, are you out there and ready to go?
All right, thanks, Judd. So yeah, pleased to be with you all today remotely. It's been a couple workshops since I joined you last, and just report on a couple things we've been up to lately. Oh, this is weird. Now I can't advance. All right, there it goes. So I'm going to talk about two emerging technologies that I've been involved with. We funded both through NOAA's SBIR program, that Small Business Innovation and Research Grant Program. They're both companies in Southern California, and I think that there's technologies, they're leaders in them, and I think they're going to become relevant to us here in the near future for oil spill response and cleanup kind of work. The first is working with Planck Aerosystems out of San Diego with their ACE, that's their autonomous control engine for small VTOL UAS, which allows them to take off and land autonomously from moving boats. And the second is from a company called SARA Incorporated, and that's their PANCAS acoustic noise sense and avoid system for small UAS. And basically it uses an acoustic sensor to sense intruder aircraft and then signals the operator that there is something to avoid, and would then direct the operator to bring the UAS down. Also share a couple concepts that we're hoping to test this COVID year out here in the Channel Islands Sanctuary of other technologies. And then I'll mention some new initiatives in NOAA, three strategies were recently published just earlier this month on artificial intelligence, genomics and genetics, and unmanned aircraft and surface vessels. So the first project is, as I mentioned, with the autonomy for the takeoff and landing, working with Planck Aerosystems. And so we partnered up with the Navy and the Coast Guard to look at this technology. And we had a couple of objectives. We really wanted to increase the safety for operators on vessels from really recovering the small UAS. Taking off isn't so hard. It's getting them back on deck, and it scared me for years, seeing people, reach up and grab them out of the sky, especially in, remote areas, fearing an injury. Also, Planck Aerosystems has a variant of the drone that they were building that operates from a tether, and it can stay aloft indefinitely with power going up the tether and data coming down. And we thought that might have some really good application, both for missions that we're involved with regularly, especially out in Hawaii and sometimes in California, which is disentangling whales, where we need a persistent view from above, but also for oil spill characterization, et cetera, from boats. So we went ahead and tested this, what was then called the Shearwater UAS, which was a UAS that Planck built on their own. It was their own sort of proprietary air vehicle. We tested that both in the RV Shearwater in the Santa Barbara Channel and off the Danny Sea, which is a big steel salvage vessel. We went ahead and started off easy, and then went further, both with the weather and the sea state, and we were able to successfully have this air vehicle take off and land autonomously in up to 18 knots of wind at sea state 3. So it's pretty impressive. Then I went and we did a mission out in 100 miles off of Galveston, a science mission using the air vehicle to try and help us identify giant manta rays for tagging when they were just on and below the surface. And the Navy also integrated this system onto a bigger drone, and we took the big 200-foot-long MV Independence out and had good success with the autonomy. The problem was the air vehicle itself, the interface to it was pretty kludgy. It was like, it was okay to fly it if you were the engineer that designed it, but it was kind of hard for everybody else. There were buttons on the controls that we didn't know what they did. And saw a couple of glitches in it from a reliability standpoint, but we really thought they had something there. We continued doing some testing in San Diego and later out in Maui. We trained some pretty adept DJI drone operators on the system out there. And then we kind of went back and started negotiating with Planck about what we really needed out of a system, which would be a much more friendly user interface. And ultimately what they did is they partnered with Parrot, who makes a lot of drones, and recently was accepted. Their Parrot Anafi USA Gov drone, which is shown in the upper right here, is one of the quote blue drones that's that the Army's recognize. So they have these blue drones have airworthiness. They're built from in the US with US components, so federal agencies don't have problems procuring them. This one's pretty simple to operate and has waterproof and weatherproof. It can fly in the rain even. So this is getting more towards the COTS kind of commercial off-the-shelf technology we wanted. And we're taking delivery of a couple of these by the end of next month. So we expect that to go well. Just a quick page, anyone can look this up on the internet. The beauty of the Parrot Anafi USA Gov, besides again meeting all these government procurement specs, although they are expensive at about $13,000 each, luckily it's got the same hand controller and interface as the off-the-shelf Parrot Anafi that you can buy at Best Buy for like $1,000. So you can use the cheaper ones for training. They won't have the software architecture to include the OEM Parrot autonomy, but they're good, cheap trainers. So the second project I wanted to talk about again is this acoustic deconfliction project. And luckily, with a little help from the Coast Guard, we were able to conduct a final phase of this integration and test out at Joint Base Cape Cod in September. I couldn't go because NOAA wasn't letting us travel, A, and well, B, I'd had some shoulder surgery. But in any case, some pretty impressive results. So PANCAS is an acronym for a passive acoustic non-cooperative collision avoidance system, okay? And so here you see it integrated onto the Puma, both the sensors on the wing and then inside the fuselage in the transit bay, it's got the signal acquisition processing system. And so what it's doing again is listening for non-cooperative aircraft. All it is passive. It's already screening out the noise that the propeller itself makes at the Puma. It's got a 360-degree field of regard, and it doesn't matter what the weather is or the visibility, right? It can hear no matter what. It can hear through clouds, fog, etc. And we think that this technology will help for remote and offshore beyond visual line of sight operation. We're hoping to get a Part 107 waiver in the next phase of our testing, but certainly for coastal and shipboard operations, rural areas, we think this might be a decent self-contained system that will help again beyond visual line of sight in low-risk areas. So the concept of implementation here is, of course, the small UAS is listening for aircraft sounds via the PANCAS system. When an intruder aircraft is picked up by PANCAS, it alerts the operator on its ground control station that something's been detected. It's monitoring that, and it declares that you need to do something when it becomes a collision threat with enough time to act. And then it requests this avoidance maneuver. And in the next phase of this, we're planning on incorporating the avoidance maneuver autonomously into the Puma's ground control system, which already has the ability with pressing a single button to put the Puma into a deep stall to recover it. So the next phase, again, will, at least on the Puma, that would be automatic. So we flew for 3 days, or I should say our friends and colleagues did, and they flew the PANCAS system on the Puma against 3 different representative aircraft that we were able to scare up. A Cessna, representative of general aviation, Coast Guard HC-144, heavy twin engine turboprop, and an HH-60. And the system worked really well and reliably. There's a lot of data I can provide people after the fact, but it had 100% detection of all these aircraft types on every flight from every direction. This is just one slide from a slide deck showing a summary flying against the H-60 on 10 out of 10 on endurance cruise flights and at max cruise speed, 7 out of 7. So there are 17 passes. And you can see the PANCAS system alerted the UAS operator from between 1.5 miles and over 3.5 miles away from the with the aircraft from the Puma. So again, pretty successful. We gathered data that we'll use for the FAA waiver for a beyond visual line of sight 107. We have our next steps are basically a phase 2 funded through NOAA proposal that's in the works right now, and that's got 2 objectives in it: develop waterproof packaging for the system to be used in a maritime environment, and again, as I mentioned, integrate the autonomous Puma auto land command connection there. So a couple of things that we're fooling around with doing here, if we can get out in the field this year, we'll be putting together a WAM-V autonomous surface vessel. I've got a picture coming up, integrated with one of these Parrot Anafi USA drones that's running the Planck ACE software. So having them operate autonomously where the aircraft is taking off and landing on the surface vessel. And we'd equip them to do some mapping. So the mapping in shallow areas, intertidal to 10 meters of depth, and the WAM-V would be, looking at the bottom, and the air vehicle would be imaging from the top and using surface for structure for motion analysis to try and put those together. There was an earlier attempt that was not autonomous out at Santa Cruz Island that we'd like to build on. And then we have a concept to fly what had been the Sanctuary SAMSAP program, where for 15 years there was weekly flights of aircraft doing a figure 8 around the Channel Islands, collecting data on human use patterns and doing critter counting. And we'd like to try that now on an unmanned aircraft, similar to the Jump 20 that Christian Hasselheimer put together with a test we did off of Gaviota a couple of years ago. This would be on an L3 Harris FER 90, equipped with an Orion HD 80. So we think with this local provider, Overwatch Aero, out of the Solvang area, and their relationships with the Santa Barbara Tower, plus our MOA with Point Mugu for making the warning areas around the Channel Islands hot, we could at least do this as a proof of concept. So this is what those systems look like. URL at the lower right for WAM-V, and these surface vessels come in various sizes. This larger photo actually shows one of the older Planck Shearwater UAS taking off and landing autonomously on on a WAM-V. It's actually been integrated before. This idea is interesting to my home program because it could conceivably be scaled to a larger autonomous surface vessel and a larger UAV that could conceivably someday scaled up provide surveillance and reconnaissance of larger marine protected areas and fisheries. So again, the snappy acronym for SAMSAP flown on a UAS, we're calling Son of SAMSAP. It's kind of got a ring to it. Again, this would be a proof of concept, but potentially done routinely. The lower left is the NOAA aircraft that supported that for a period. And in the center there, you see the L3 Harris FER-90 aircraft. NOAA is actually looking at the variant of that that's a smaller version, that's the FER-55 for taking off and landing from our large ship decks. So that testing is ongoing, and a lot of agencies are looking for medium altitude, long endurance aircraft that can perform surveillance and reconnaissance and science missions from oceanographic research vessels. And this technology is one of the contenders for now. Just a sheet on the Overwatch Aero system, which you can find online. And finally, these three strategies that NOAA published earlier this month, you can look them up if you like to see them. They were created at the end of the last administration. They were actually, they've been sort of dumbed down a little bit from the amount of detail that had originally been in. They were actually transition plans for operations, which had bullets and objectives and attributed responsibility to various offices in NOAA to perform them. But I believe these were published this month. They're being actively pursued, and certainly the unmanned system strategy is being funded. Last fiscal year, NOAA received about $16 million of new money from Congress to develop capacity for operating maritime unmanned systems. So that's surface vessels, undersea autonomous vessels, and aircraft. And they're setting up a global operations center for gliders, and we're doing a lot of work to develop and vet requirements. There are funding proposals that are coming out during the year. There's one for artificial intelligence that is open for a couple more weeks, and then another for unmanned aircraft projects that hasn't quite been published yet. So these are RFPs that require a NOAA PI to be the principal, but can be partnered with industry, academic, or other state and local agencies. So there's the three strategies: the unmanned system strategy, artificial intelligence and machine learning, and genetics and genomics, eDNA analysis and the like. And so they're thought to be complementary technologies and strategies. We're seeing new money, at least last year and this year, and they're really looking at adapting the fleet to incorporate and to be able to successfully operate and launch and recover the systems that will take advantage of new sensors and new computing power to analyze the data. So I'll stop there. If there are any questions, that was my last slide, and I appreciate everybody's patience and interest in what we're up to. Thank you.
Yeah, excellent, Todd. Very informative, and yeah, real good. Jenna, I think I see a couple of questions there.
Yeah, it's one question. What is the approximate weight of the system that is on the PANCAS?
Yeah, great question. It's just ounces right now. It's like a pound. And they're working also to reduce the form factor of that so that it can fly on vertical takeoff and landing UAS as well. So it's still in development, but it will eventually have a smaller form factor and reduce power requirements as well.
Is that it for questions?
That's it for questions.
Okay, Todd, again, thank you for the presentation. Look forward to working with you in the future and flying along the seeps in Santa Barbara. As long as we stay below a couple of 100 feet, right? Yeah.
Well, yeah, the big UAS fly a little higher, actually. They're you know, above 1,000 with a COA. But I will say that FBR 90 also, besides flying, you know, it's EOIR that's got AIS on board and a comms relay, and you know, with a persistence, it doesn't have to be that brand or that version, but you know, 16 to 18 hours in flight, that could conceivably take care of some of our comms problems for, you know, working below bluffs, just relaying whether it's a cell phone or VHF right through something that's just doing donuts in the sky if it's not mapping. So,
All right, thank you. That's great work, and we're going to move on.
thank you.
Yes.